This example involves converting between two compound units that are both made up of several other units. The question is, convert 8.31 Newton meters per mole Kelvin to foot-pounds force per pound mole Rankine. This question is based on the units used to measure the ideal gas constant, so it is actually based on a real-life example, believe it or not. Given the correct conversion factors, you should be able to answer this question without even knowing what these numbers and symbols mean. We'll start, as we always do, by setting up the original amount as a fraction. Write it as 8.31 newtons times meters over moles times kelvins. Now look at what units the answer is supposed to be in. We need to change newtons to pounds force, meters to feet, moles to pound moles, and kelvins to rankines. Let's start with the newtons to pounds force conversion. We can use the given information that 1 newton equals 0.2248 pounds force. We need a conversion factor as a fraction with newtons on the bottom, because newtons is on the top in the original amount. So starting with the original amount, we need to multiply by the conversion factor here, 0.2248 pounds force over 1 newton. Because this will make the newtons on the top in the original cancel with the newtons on the bottom in the conversion factor. Now we could do this operation now, do the 8.31 times 0.2248 and see what we get. But it is actually easier to do this question all in one step by multiplying by the other three conversion factors at the same time. So let's move on to the next conversion factor, and you'll see what I mean in the end. Now to change meters to feet, we have the given information that 1 meter equals 3.28 feet. And we need to make that into a conversion factor. We need meters to be on the bottom and feet to be on the top, so we multiply by 3.28 feet over 1 meter, and I'll add that to the sort of multiplication train we have going here. Now we do the same thing with kelvins to rankines using the information 1 Kelvin equals 1.8 rankines. However, this time I need kelvins to be on the top to cancel with the kelvins that were on the bottom here in the original. Again, I just put that next to my other multiplications. Finally, to change moles to pound moles, I need to put moles on the top to make it cancel with the moles on the bottom in the original, and pound moles on the bottom. So I'm going to need to multiply by 1 mole over 453.59 pound moles. Now we have this long line of multiplication that we're going to do all at once, but it's best at this point to check to make sure all of our old units are going to cancel. So you can see that newtons on top here is going to cancel with newtons on the bottom here. Meters here will cancel with meters down here. Kelvins on the bottom here is going to cancel with the kelvins on the top in this one. And moles is going to cancel with moles on the top way over here. So that only leaves pounds force, feet, rankines, and pound moles in the right places for the answer. And just so you can see how all the units are canceling out, I'll put it on a new line so you can see all the cancellations. Now that I'm confident that I'm going to end up with all the right units for the answer, I'll put down the units for the answer first. And now all that's left is to do the multiplications with the numbers. After working through the multiplication of the fractions, we end up with 8.31 times 0.2248 times 3.28 on the top, and 453.59 times 1.8 on the bottom. So using my calculator, that gives me 6.127 for the top and 816.462 for the bottom. Take the top and divide by the bottom, that gives you the final answer of 0.0075 pounds force feet per pound mole Rankine. And that is the final answer. So I'll write down my final statement. Confidently stating that 8.31 Newton meters per mole Kelvin is the same as 0.0075 foot-pounds force per pound mole Rankine. Or if you want, you can write this in scientific notation as 7.5 times 10 to the power of -3 foot-pounds force per pound mole Rankine. Now, is there any real way to check this answer? It's definitely a little hard to tell just by looking whether the answer makes sense. These aren't, we normally wouldn't use this kind of compound unit in real life. This is kind of an extreme example. So really all you can do is check over all the steps, make sure all the units were canceled out right, and check your calculator work. And I can tell you this is the right answer, but if you want to check it for yourself, it's always a good idea to make sure.